Good morning, students. Today we are going to see the topic BIOT law. For considering with this BIOT law, we are going to consider a conductor. So this is a conductor, and from this we are considering a point P, and that point P is at a distance R from the center. Okay, so we have to mainly find with dB. So what is a dB is that is a change in the magnetic field. So that is what we are going to find here. First, BIOT experimentally observed that the magnitude dB is at a distance r and it varies. So what are the things it depends and what are varies is first it is directly proportional to. So it is directly proportional to three things. First one is strength of the current I, then magnitude of the length, then sine of the angle. Okay, strength of the current I, so it is directly proportional to the value of I, then directly proportional to the length element which is dl, and we can say it as theta because the angle sine of the angle, so it is sine theta. Okay, so these three things it is directly proportional. Then it is inversely proportional to the square of the distance between the point P and the length element. That's distance we are writing as r, so it gives r square. Okay, so it is inversely proportional to r square. It is directly proportional to what are the things? First one is I, then dl, then sine theta. They are all directly proportional and inversely proportional to r square. Okay, so this we are going to write as equation. We can say that, so what varies here? So the varying one is what? Magnetic field. So dB, is it not? So we can write the equation as dB proportional to I dl sine theta by r square. So how you are writing this is, as I have told you, it is directly proportional to the current, directly proportional to dl and sine theta, and inversely proportional to r square. So we are writing in division. Now here we are having a proportionality. To remove this proportionality to equal, we are introducing a constant. That constant here is k. Okay, and next is we are writing the value of k. That value of k is given by mu naught by 4 pi. Okay, so value of k is mu naught by 4 pi, and that is in SI units, and k is equal to 1 when you are measuring in CGS unit. Okay, now substitute this value of k at this place. Okay, so this equation becomes as dB is equal to mu naught by 4 pi I dl. Instead of sine theta, I am writing as cross r cap. Here this value of r cap is the unit vector. So what is meant by unit vector? That value is equal to 1. Okay, so ideal cross r divided by r square. So dB is equal to mu naught by 4 pi ideal cross r cap divided by r square. Okay, so this is the equation for BIOT law. Clear? Then next is we are going to see with the integral form of this. So when you write integration, that becomes this integration of ideal cross r cap. We are taking this mu naught I by 4 pi outside because it is a constant value. Okay, then if the point P lies on the conductor, then theta is equal to 0. So it is given the value of theta to be equal to 0. If the value of theta is equal to 0, here is the value of theta. If it is equal to 0, then we can say that the dB value is 0. Okay, because when you substitute this value of theta in this sine theta. Okay, so we know that dB is equal to mu naught by 4 pi I dl sine theta by r square. So sine theta is here. Instead of sine theta, we are writing as sine 0. Sine 0 value is what? 0. So this dB fully becomes 0. Next is when it is perpendicular, then theta is 90. If theta is 90, then dB is maximum. Okay, so when theta is 90, what happens to the value of dB? Then the value of dB is maximum. Okay, so this is a condition for the BIOT law. Yes, clear? Then next is we are going to see some of the similarities between Coulomb's law and BIOT law. We have already studied with Coulomb's law in first lesson. This is BIOT law. So when you see the similarities, they both are similar in the electric and magnetic fields. இது ரெண்டுமே எப்படி இருக்கும்னா they both obey the inverse square law. So ரெண்டுமே inverse square law obey பண்ணும். Okay, so they are long range fields, so they can say to be a long range field. Then they obey, first they obey inverse square law, next they obey with the principle of superposition. Okay, so they obey with the principle of superposition. In magnitude, that can be written as E proportional to Q and B proportional to I into dl. Okay, so magnitude we are writing E proportional to Q and E is proportional to Q and B is proportional to I into dl. Okay, so they obey inverse square law and they obey principle of superposition. Yes, so these are the similarities of Coulomb's law and BIOT law. Okay, so next is we are going to see with what are the difference between this Coulomb's and BIOT law. So what are the differences? First one, they are produced by scalar. Okay, so that is the first one. Here it is produced by a scalar source, and here when you see this is produced by a vector source. Okay, so here it is produced by a scalar source, here it is produced by a vector source, then it is directed along the position vector. So if this is a position vector, then the electric field is along the direction of position vector. Here it is directed perpendicular to the position vector. So if this is a position vector, here is a field, that is a magnetic field. Okay, then it does not depends on the angle, it depends on the angle. Okay, so it does not depends on the angle, it depends on the angle. So it is produced by a scalar source, it is produced by a vector source, it is directed along the position vector, it is directed perpendicular to the position vector, does not depends on the angle, and it depends on the angle. Okay, so these are all about the BIOT law. So we have just seen with what is BIOT law, what are its similarities with Coulomb's law and difference with the Coulomb's law. Okay.